Now, as I see with this, the interesting thing out here is that in ungrouped data, my xi is the observation, but in case of this, for group data, I have my observation xi to be the mid value of the class interval. How do you think that I can assume the mid value of this class interval to be the observation? And how do we compare with the mean as obtained for an ungrouped data, where I got the mean as 56.3 approximately, and when I calculate the same mean for the group data and for the same problem of the same data, I got my mean as 62. This is because the mid value xi here is assumed to be with the mid of the class interval. That is, it is assumed that when I take the mid value, it is a very important note that it is assumed. So it is assumed that the frequency of each class interval is centered around its midpoint, is a very important note which we need to make when we connect this with the mid value of class interval, that is xi for the group data, and for the ungrouped data it is the observations which we identify. So it is purely on the assumption that we assume the frequency of each class interval is centered around its midpoint. Therefore, the mean as obtained in group data, which is for 62, and the mean of ungrouped data, which obtained as 56.3, never match, but they are approximately equal because of this assumption. For a grouped and ungrouped data, finding the mean using frequency and observations, fi and xi respectively. So let's compare the two means as obtained for the ungrouped and the group data respectively. So as I take the mean for ungrouped data and the grouped data, for the previous example problem, I get my mean for this being 59.3, and here my mean is 62, is what I obtain for each of the means for the same problem. Therefore, as I take in my example problem with this and this, makes me understand that this is on no assumption but on direct observations. Therefore, the value I obtain here in this case of ungrouped data is exact mean. But when I take in case of this, where the value as obtained here is approximate mean, for the given grouped data, is how we differentiate between obtaining the value of mean as 59.3 for ungrouped data, which is the exact mean because it is not on any assumptions. But when I take the mean as 62, this is approximate mean because this is on assumption that frequency is centered around the mid value of the class interval, is what we have taken. So each class interval frequency is centered around its class interval. Therefore, this is how we differentiate between the grouped and ungrouped data, where the ungrouped data gives us the approximate mean, the exact mean of the given observations. So in this case of finding the mean using the group data is called the direct method. So calculating the mean through assumption in the group data is by the method called the direct method, is how we identify here. And next comes the other method in finding the mean, which we are going to see in the next session. Now here, let's see how I can find mean using assumed mean method. So one of the method through which I can find mean. So when do we use this method? Usually when the values of fi or xi are very large. That is, when I find the mid value xi, then clearly I can find that the mid value of this is 35 by 2, which is 17.5, and 65 by 2, which is 32.5, and 95 by 2, 47.5, and 125 by 2, 62.5, and 155 by 2, and finally 185 by 2, which is 92.5, is how I get the different values of the mid value. Now, usually this method, called the assumed mean method of calculating mean, is used when the values of xi and fi are very large. That is, when the class interval has very huge numbers like 1000 to 2000 or 2000 to 3000, then the mid values become very large, and then in that case we use the assumed mean method, because assumed mean method reduces the values as obtained for fi and xi. Now, coming to this, let's see how the assumed mean is calculated. The word assumed mean itself shows that we assume one of the value, which is called assumed mean. So let's assume one of the value. Generally, for all the xi values which I obtain here, which is the mid value of the class interval, we have already discussed this in the previous session. We try to take the middle, which is either this or this. So usually we take the midpoint or the middle value of the entire data, which helps us because each of the middle value is based on the extremes on the left and extremes on the top, or extremes on the bottom, or left and right. Therefore, for these I can choose this or this as the assumed mean, is how we make it as a rule. There's nothing wrong if we take other values also as the assumed mean, but generally the rule says that we take the middle values assumed as mean. So let me take this value, which is 47.5, and lying between each of the values from 17.5 to 92.5 as the assumed mean. Generally, my assumed mean is denoted by A. Therefore, assumed mean A in this case is 47.5, which I have considered for the given problem. Now, taking the assumed mean A as 47.5, let me calculate how the next column, that is deviation, is calculated. So let's see how we calculate the deviation, which is denoted by di. The deviation denoted by di is related with the assumed mean is xi minus a. So therefore, my xi minus assumed mean, that is each of the xy subtracted from the assumed mean, will give me the deviation dy, as with the formula di is xi minus a. So let's see how this column is extracted from the formula. Now, as I see, my first xi, which is x1, is 17.5. Therefore, when I substitute and simplify, I get this to be x1 minus a, that is 17.5 minus a, which is 47.5, which on simplification gives me negative 30. Here you get a negative value, so deviation can be a negative value in this column, to make a note. So when I subtract the assumed mean 47.5 from the first observation, or the mid value 17.5, I get minus 30. Similarly, proceeding with x2, which is 32.5 minus a, x2 minus a, which gives me 32.5 minus 47.5, gives me 32, 47, 52 and 15. So this is negative 15 is what I get for the second row. Similarly, for x3 equals 47.5, I get 0 because the assumed mean is 47.5 itself. Subtracting this from the same number gives me 0. And then next, coming to 62.5 minus 47.5 gives me 50 and 12, 15. So I get this to be 15 is what I get, this subtracted with this. Similarly, 74.5 minus 47.5 gives me 30. And then this 47, 50, 45 is what we get for each of the values minus 30, minus 15, 0, 15, 30 and 45 is what we get for the deviations di. Next, the next thing I'm going to calculate here is fi di. Now we come to finding the deviations for each of the observations or the mid values x1, x2, x3, x4, x5 and x6. Then the next column is to find fi into di, where I know my fi from the second column and di from the fourth column, which I'm going to multiply, where I get 2 times of minus 30 is minus 60 and 3 times of minus 15 is minus 45, and then 7 times of 0 is 0, and then 6 times of 15 90, 6 times of 30 is 180, and 6 times of 45 240 and 280 is what I get for each of these curves out here. Now as I find clearly, when I add each of fi di, I get sigma fi di. So my sigma fi di is nothing but when I add each one of them. So let's see what I obtain when I add minus 105 plus 380, 380 and 160, 480, 540, 630. So 630 minus 105 is 530 and 525. Therefore, I add up to find sigma fi di, which I get as sigma fi di. When I add each one of them, I get this to be 435. And when I sum up fi, the frequencies, I get sigma fi is 30 from the second column and sigma fi di is 435 from the fifth column. And then I have my deviation using the assumed mean method. My mean using deviation is calculated using sigma fi di by sigma fi. So with the deviation, the mean using deviation d bar is given by sigma fi di by sigma fi, and therefore this on further simplification gives me 435 divided by 30 with each of the substitutions here, which in turn gives me 14.5. But this is not the mean, this is only the d bar which we have calculated. Then how do we find the mean by assumed mean method? Now the deviation which I have obtained is nothing but using the assumed mean. So how do you connect this with mean is the biggest question. So let's see how the mean is connected with the d bar, x bar and d bar comparison. Now let's see how I can comparing d bar and x bar. Now as I have found the formula for d bar, which is sigma fi di by sigma fi, is what I found for the formula of d bar. So let's see how x bar can be derived using this. So therefore, coming to this, we know that the deviation di is clearly calculated using xi minus a is what we obtain, because di is simply xi minus a being the assumed mean and xi being the mid value of the class interval or the observation of each of the class interval. Now when I split this summation, I get sigma fi xi minus sigma a times of fi whole by sigma fi is what I get when I split the summation expanding through the brackets, fi xi minus a times fi. So proceeding further, I find that when I split this, I get sigma fi xi by sigma fi, which I obtain when I split each of the terms, minus the second term reduces to sigma a times fi by sigma fi is what is modified from the previous statement. Now, as I simplify this further, I obtain as sigma fi xi by sigma fi minus a times sigma fi by sigma fi. Because a is independent of the index I can bring a out of the summation. This is common in each of the summation terms. So therefore, this being independent of I comes out, and therefore this reduces to a times sigma fi by this. Thus, this gets cancelled, and we know that this is nothing but the formula for mean, which is x bar, because x bar is sigma fi xi by sigma fi. Therefore, I can denote this first term with x bar minus a. Therefore, finally, I have the relation which says d bar is x bar minus a. That implies my mean is given by a plus d bar, is how I understand the relation between the d bar and x bar. The mean, the exact mean, and the mean using the deviation are compared using x bar equals a plus d bar, where a is the assumed mean. Now let's see how we can calculate x bar using the assumed mean method for the previous problem which we have discussed. Now we have already identified for the previous example that the assumed mean is considered as 47.5, and then which was the mid value of the column with xi's. And then we have calculated the d bar to be 14.5. So with these two values as obtained for the previous problem, let's see how we can calculate the mean, that is x bar. So substituting these two values in this formula, I have x bar equals a times plus d bar, which is 14.5. That implies my mean is calculated to be 47 plus 14, 57, 62. Therefore, the mean which I obtain using the assumed mean method is 62 for the previous problem, with number of students in the class and number of marks which they got in the subject of mathematics out of 100 is how we calculate. Therefore, this makes us understand that by assumed mean method, my mean equal to 62 implies on average the entire class marks is 62. Now let's see how we can calculate mean by the third method, or the next method called the step deviation method. Now before we start with this example problem, now we need to know the essentiality of using this method. Why do we need to use this method, or when do we need to use this method? Now coming to step deviation method, this method is used to calculate mean only when we have each of the deviations with multiples of the common factor. Now as I can see, for the previous problem which we have discussed, we calculated the deviation using the mean deviation or the assumed mean method for di as minus 30, minus 15, 0, 15, 30 and 45. So we have calculated this clearly from the previous problem. So taking with the same problem of the previous session, let's see how we have the common factors. Now each of minus 30 can be written as negative 2 times 15, negative 1 times 15. This is 0 times 15, 1 times 15, 2 times 15 and 3 times 15. As I see that each of the deviation values are multiples of the common factor 15, therefore in such cases we can use step deviation method. So let's see how step deviation method can be used for these kind of problems which give the deviation with the common factor. If we do not get the common factor, it's not suggestible to use step deviation method for the problems which do not have the common factor for their column with di's, that is deviations. So because we have the common factor 15 in each of the cases of di's here, I very much apply step deviation method for this example problem. To start with, my step deviation denoted by ui is given by the formula xi minus a by h, where a is assumed mean and h is class size, and a is assumed mean and then my xi is each of the observation or mid value of class interval is how we obtain the formula for step deviation. So step deviation ui is given by xi minus a by h. So let's see how I can calculate ui, which is xi minus a by h, using the formula. Now, as in the previous case, we have seen that the assumed mean is the middle of the entire values of xi in the column. I take either this or this to be the assumed mean, but here I assume this to be the mean. Therefore, my assumed mean is 47.5, which on subtraction of a gets me deviation this, that is, this is clearly di by h. So my assumed mean restricts di, which in turn gives me the formula for this as di by h, where di is the deviation and ui is the step deviation. So finding the step deviation from deviation is what we do in step deviation method. So let's see how the step deviation for each of the class intervals can be calculated respectively for their frequencies and class sizes. Now, as I clearly see here, the class size 10 to 25 has 15 students in each group. Therefore, my class size h is 15. In this case, my class size h is 15 and my assumed mean a is 47.5, through which I calculate the ui's for each of the rows or each of the class intervals. To start with the first row, here I can calculate ui as di by minus, so di, which is minus 30 by h, which is 15, gives me minus 2 as ui. Similarly, my di, which is minus 15 by class size, which is 15, gives me negative 1 as my u2 for the respective class interval 2, second class interval. Similarly, 0 by 15 gives me this 0, and 15 by 15 gives me 1, and 30 by 15 gives me 2, and 45 by 15 gives me 3. Therefore, each of the ui's are minus 2, minus 1, 0, 1, 2, 3. So using this, next immediately I try to calculate fi and ui and see how my fi into ui reduces to. So I multiply this times this and see what exactly I get. 2 times of minus 2 is minus 4, and 3 times of minus 1 is minus 3, and 7 times of 0 is 0, and 6 times of 1 is 6, 6 times of 2 is 12, and 6 times of 3 is 18, is what I get in terms of fi and ui. When multiplied fi with ui is what I get. Now next, using this, I would like to calculate the sum of fi and ui. That is, when I calculate sigma fi into ui, I add each of the values and then I get summation fi ui, ranging from first class interval to the sixth class interval. So let's add this. Minus 4 minus 3 minus 7 plus 0 minus 7 plus 6 minus 1 plus 12, 11, 11 plus 18, 29. So my sigma fi ui is 29, and of course my sigma fi is always fixed in each example problem because the same problem is considered in each of the methods. So therefore my sigma fi is already calculated to be 30, through which I calculate the step deviation mean using the step deviation method. So let's see what is the mean formula using the step deviation method. So let's see how we can compare u bar and x bar. So before that, we have u bar as sigma fi ui by sigma fi. That is, calculating mean using the step deviation method, I have my formula for u bar, which is sigma fi ui by sigma fi, where my ui is xi minus a by h. H is the class size, a is the assumed mean, and xi is the mid value of the class interval for the respective I. So let's see how I can derive x bar from this formula of u bar. So coming to this, that implies when I substitute in place of ui, I substitute this value, I get fi times xi minus a by h by sigma fi. Because ui is xi minus a by h, I replace ui with xi minus a by h. But this on expansion gives me sigma fi xi minus a 1 by h of sigma fi. Because h is independent of I can bring this 1 by h outside and then write all remaining terms inside. Now next what I do is I split this, where this is u bar is 1 by h times of sigma fi xi minus sigma a fi by sigma fi is what I get when I split the factors from the bracket. So fi xi minus a times, again a is independent of I, can come out of the summation. So therefore this reduces to u bar equals 1 by h times of sigma fi xi minus a times of sigma fi by sigma fi is what I get when I take a outside the summation independent of I. Now when I split each of the terms, I get this to be sigma fi xi by sigma fi minus a times sigma fi by sigma fi on splitting the denominator into two different terms. This clearly gives me the cancellation such that I get this to be 1 by h of sigma fi xi by sigma fi is x bar, as we all know clearly, minus a times is what we get for u bar. Therefore, if I wanted to extract x bar, I take only x bar on the left, and further simplifying using the cross multiplication, I get h times of u bar is x bar minus a. That implies x bar is a plus h times of u bar, or x bar is a plus h times of u bar, which is sigma fi ui by sigma fi is what we get the relation between x bar and u bar, with a as assumed mean, h is class size, fi is the frequency of each of the class, ui is the step deviation of each of the class, is how we substitute and calculate. So let's see for the previous example problem what would be the mean using the step deviation method. So coming back to the previous example problem, I clearly have my assumed mean is 47.5 and my deviation, which I obtained as 1429 over 30, is what I got here. So using these values, let me see how my x bar, which is 47.5 plus 15 times of u bar, that is 29 over 30, gives me 15 ones, 15 twos. So 47.5 plus 14.5 is exactly 62. That is the mean of the given data using the step deviation method is 62. It is as same as the mean obtained from assumed mean method. Therefore, the method which you are using does not affect the value of the mean which you obtain. So you take whether the step deviation method or the assumed mean method or the direct method, we get the mean to be fixed as the same value. In this case of step deviation method being 62 is an example problem. Now coming to the learning outcome of all the three methods which we have used, that is coming with the learning outcome of the three methods which we have discussed in the session, the first being the direct method of calculating the mean, then assumed mean method, and thirdly the step deviation method. Are the three methods which we have used in calculating the mean. So in this case, the first learning outcome is that we use this method if data is very large, we used grouped data. And if data is reasonably sufficient, then we can use ungrouped data, is what we have seen through the learning outcome. Now, in assumed mean method, we use this method when we have very large values, used when xi and fi are very large, or the class interval is very large, that is with very large values or the numbers which are too big, then we use assumed mean method. Then the step deviation method is used when each di, that is the deviation, has a common factor. Then we divide that with the class interval or the class size, and then this method is used when each di has a common factor. So the learning outcome here is that different methods have their own limitations in its usage, where if I have very large data, I may not use. If I have the data with xi and fi being too large values, the values being very large, then we don't use the direct method for such data. Or we have each of the di does not have a common factor, then this method may not be suitable, where we switch on to assumed mean or the direct method, is how we understand the different methods using them. Now, interestingly, here when I have this x bar is a plus h into u bar, then the values of a and h, what we choose, where the mean which you assume and h, the class size which we choose, can be of different options, but still the mean as we obtain will be the same, does not affect the actual mean which you are calculating from this formula. So this is a very important note, because generally assumed mean, different students assume different assumed means, and different students assume different class sizes based on their suitability, but ultimately that does not affect the step deviation method, where you're calculating the mean using a plus h u bar, which is irrespective of a and h which we choose. Choosing of a and h is only a rule, but not a strict condition out there. We assume on the middle of the mid values of x, as we have discussed in the previous sessions. So with this, I end with mean with the three basic methods as we discussed out here.